Hello, my name is Matthew Malgi, and today we will be solving question number 12 on page 113 of the textbook. The main purpose behind this video is to walk through the steps involved in solving a revenue-based function question. So let's get started. The question reads, the weekly revenue for battery sales at Discount H Hardware can be modeled by the function r of x equals negative x squared plus 10x plus 30,000, where revenue, r, and the cost of a package of batteries, x, are in dollars. The maximum revenue occurs when a package of batteries costs $5. Write detailed instructions using appropriate calculations for the rate of change in revenue to verify that the maximum revenue occurs when a package of batteries costs $5. As you can see, we will need to solve using concepts of rate of change covered in Unit 1. What the question is asking is that we need to confirm that when a package of batteries costs $5, a maximum revenue is produced and no other cost will generate more revenue. So first off, we can model this function by drawing a graph, which I've already done. As you can see, cost in dollars is on the x-axis, while revenue in dollars is on the y-axis. What the graph illustrates is as the cost increases, so does the revenue until a certain point. Then as the cost continues to increase, revenue begins to decrease. Next, we can algebraically solve to find our revenue when the cost is $5. We can do this by plugging x equals 5 into the original equation. So the original equation states that r of x equals negative x squared plus 10x plus 30,000. So now I'll plug x equals 5 into the equation. So this equates to $30,025. So what this is telling us is that when the cost of batteries is $5, the revenue is $30,025. Next, we can draw a tangent line at x equals 5. Now that a tangent is drawn, we can calculate the instantaneous rate of change at x equals 5 using the following formula. Because we do not have 2 points, we can still solve by using a point slightly to the left and a point slightly to the right of x equals 5. So the general formula for IROC at x equals 5 is y2 minus y1 over x2 minus x1. Like I said, because we do not have 2 points, we'll be using a point slightly to the left and a point slightly to the right of x equals 5. So the new equation reads y of 5 plus 0.01, 0.01, minus y of 5 minus 0.001, all over 5 plus 0.001 minus 5 minus 0.001. So now we need to solve for what each of these values equates to. So we can call this the left side of the equation and this the right side of the equation. So to solve for the left side, we need to plug this number into the original equation. So the original equation states negative 5.001 squared minus 10, or plus rather, 10 times 5.001 plus 30,000. So this equates to approximately $30,025. So now I'll solve for the right side. So for the right side, we'll be plugging 4.999 into the equation. Plus 10 times 4.999 plus 30,000. So this as well equates to about $30,025. Now this is our new Y1 and this is our new Y2. So now we can plug them into our original instantaneous rate of change formula. Because the numerator equates to 0, and 0 divided by anything is 0, the IROC at x equals 5 is also equal to 0. Because there is no rate of change, and therefore no slope, we know that this is the point where revenue has reached a maximum. To check our answer, we can plug two new costs into the equation, $4.99 and $5.01. What this does is it puts a slightly more expensive, and a slightly cheaper cost into the equation just to ensure that $5 is the cost that generates the most revenue. So first I'll start with $4.99. So negative 4.99 squared plus 10 times 4.99 plus 30,000 equal to $30,024.99. So now we'll try for $5.01. So negative 5.01 squared plus 10 times 5.01 plus 30,000. And this too is equal to $30,024.99. So as you can see, neither the more expensive or the less expensive price produced a greater revenue. Due to the fact that the instantaneous rate of change at x equals 5 is 0, and neither a more expensive nor a less expensive product will generate a greater revenue, we can verify that the maximum revenue occurs when a package of batteries costs $5. This type of problem may be relevant in a business marketing career where managers must find ways to maximize revenues as well as profits. So just to quickly recap the 5 steps involved. First, draw a graph. 2, solve for revenue when x equals 5. 3, draw a tangent line at x equals 5. 4, calculate IROC at x equals 5. And 5, check your answers.